name is Laura Lindsay, and I am the soybean and small grain agronomist at Ohio State. Recently, we published a paper in Crop, Forage, and Turfgrass Management titled Partial Return Calculator to compare monocrop, relay-intercrop, and double crop production systems. My co-authors are Eric Rieker, Greg McLinch, and Alex Lindsay. In northern environments where the growing season is relatively short, most farmers will plant and harvest a single crop during a cropping year. However, due to high prices of soybean and wheat, farmers may be interested in harvesting two crops within a single year. One strategy farmers may use is a relay-intercrop system. In relay-intercropping, farmers will plant winter wheat in either September or October in 15-inch row width, and then the following year in May, plant soybeans between those wheat rows prior to harvest. This is called a relay-intercrop system and allows farmers to harvest both wheat and soybean the same year. Another system is double crop soybean production. In double crop production, farmers plant winter wheat in narrow rows, 7.5-inch row width, in either September or October, and then harvest usually around the first week of July. After harvest, farmers may choose to sell the straw, the wheat straw, and then plant soybeans, and this would be referred to as double crop soybean production. Although farmers are interested in relay-intercrop and double crop production systems due to high soybean and wheat prices, we also know that more intensive management uses more inputs within a single growing season. So it's really important for farmers and other practitioners to estimate partial economic return of these various systems. The objectives of this paper were to provide an overview of our partial return calculator, compare partial return of monocrop, relay-intercrop, and double crop production systems, and then also provide a mechanism for practitioners to use their own values to compare these various production systems. To do this, we created a profitability calculator, which is Excel-based. It can be accessed from my website and also downloaded as a supplemental file to this manuscript. When you open the Excel file, the first tab shows default prices and costs. These default prices and costs are based on Ohio State University Custom Rate Survey and Enterprise budgets. However, you can enter your own prices and costs in any of the shaded yellow cells. We also estimate soybean and wheat yield of these various cropping systems based on field research over 3 years conducted in Northwest Ohio. The second tab of this Excel file estimates gross return, costs, and partial return of the various systems. The third tab shows an estimate of phosphorus and potassium removed from wheat grain, wheat straw, and also soybean grain. We know when we harvest two crops within a single cropping year, we're also removing more K2O and P2O5 from the system. And that phosphorus and potassium has an economic value. So using our yield estimates and current prices and removal rates of these nutrients from harvested portions, we can attribute an economic value of the K2O and P2O5 removed. The last tab estimates partial return of the system, including the P2O5 and K2O removal from the harvested portions. This calculation is based on both the default values and your values, and they're color coded. So the darker green colors indicate a higher partial return, and the red shaded cells indicate a lower partial return. Looking at our default values, our most profitable system was wheat planted in the traditional narrow row 7.5-inch row width, harvested, including straw removal and sale, followed by double crop soybean productions. However, as mentioned earlier, prices and costs can vary significantly based on location and region and year. So we encourage practitioners to use their own values in this Excel file to estimate partial economic return of monocrop, relay-intercrop, and double crop production systems. We also want to thank Ohio Corn and Wheat for funding this project.